Hello, everyone. Thank you for coming in. My name is Kirill Tropin. I'm product manager on Google Cloud Storage, and today we'll talk about selecting the right storage class for your workload, whatever it might be, either content storage and delivery, big data analytics, or long-tail content that you may not be using as much. I'll have quite a few speakers joining me on stage later on in this presentation. I'll introduce them as we go, but let's start with Google Cloud Storage overall. So GCS, or Google Cloud Storage, is highly available, durable, and simple object storage. We see a lot of success in GCS across different storage classes, big data analytics, content storage and delivery, and cold storage as well. And GCS is built on exactly the same infrastructure as we use internally at Google for different object storage. And chances are, if you have not used GCS before, probably you've used exactly the same technology for any other Google products. And as I said, exactly the same infrastructure. It's exactly the same engineers maintaining and building that infrastructure. Same data center, same disk, same racks, and same network. So we see quite a lot of success across those scenarios, and let me walk you through a couple examples how customers are using DCS today. So starting from left to right with content storage and delivery, we see quite a few customers using DCS for serving video, serving music, serving images, serving any general multimedia, or just serving websites and static content through DCS. Then on big data side, if you have a lot of data, if you have petabyte scale, 100 petabyte scale, or even exabyte scale, you need to keep your data somewhere. And GCS is the place to keep your exabyte scale data, and then run compute jobs on top of that. So we have quite a few customers who run big data analytics, that run their custom pipelines, custom workloads. They do different genomics processing, different e-commerce analytics, IoT, different manufacturing modeling, and you see quite a few of those examples here. And then if you look at those customers, many of them have hot data and working data sets that they're processing regularly, but then they also have some data that they want to archive or backup for long term. And pretty much every single customer will have some sort of infrequently accessed data or some sort of cold data. Other than that, we also have customers that use DCS purely for storing cold data and long-term archive. We also have quite a few partners that use DCS to help ingest data from on-prem or help archive different enterprise data in DCS. So DCS today has 4 main storage classes, and I'll walk in detail across all of them throughout this presentation. So starting from left to right, so left, the hottest one is multi-regional storage. It's built for content storage and delivery. It's geo-redundant, so it's perfect for business continuity. If a single region in DCS goes down or something happens to that region, you don't need to worry about it. We'll keep serving your requests because your data is geo-redundant across 2 or more regions within a multi-regional location. And we see customers use that storage for streaming videos, serving images and website content and documents. Second class is regional storage class. It's built for data analytics within a single region. If you are running some compute workloads, you want to have your data stored right next to your compute workloads. You want to have lowest latency possible, highest throughput possible, and regional storage class is the right place for storing data for different analytics workloads or general compute workloads. And both of those storage classes are built for hot data, and they provide highest level of availability across our 4 storage classes. Then moving to the right, you will see 2 storage classes that are built for cold or cool data. So that's Nearline, which is built for data accessed less than once a month, and then it's Coldline, data that's accessed less than once a year on average. And we see customers use those storage classes for serving long-tail content or for disaster recovery or for archive. Beautiful part about those 2 storage classes is that they have exactly the same API as any other storage class in DCS, so it's very easy for you to integrate with those storage classes. Once you start using DCS, either it's hot data or cold data, you can use any other storage class because it's exactly the same API. And for all of our storage classes, we provide online latency, so that means you don't need to engineer around data retrievals or anything like that because all of the latency is consistent across storage classes. So let's go into detail into content storage and delivery. I'll start with our multi-regional storage, and then I'll invite product manager from Firebase to talk more about Firebase and how it's helpful for content storage and delivery. So our multi-regional storage is best for content serving. As I said before, it's geo-redundant across 2 more regions, and we provide very simple API and very simple pricing. So it's exactly the same APIs for regional storage. You just provide location name, in this case it's US, EU, or Asia, and then you create a bucket and start uploading data. You don't need to worry about your primary or secondary regions. We'll take care of all of that. It's a very simple API to use. And because data is geo-redundant, we'll take care of different failovers, and it's very good for your business continuity as well, because you don't need to worry about some region going down inside of DCS. So as I said, we have 3 multi-regional locations today. So we have a lot of different regions in Google Cloud Platform, and we're building pretty much a new region every month or every 2 months. So right now we have 3 multi-regional locations that unite multiple regions inside of them. So one of them is US, another one is EU, and third one is Asia. And customers that want to serve content either within those locations or around the world, they could choose one of those storage locations. So let me talk a little bit more about that simple API for multi-regional storage class. So here's an example of creating a multi-regional storage class with a command line utility. It's called gsutil. And I provide a type of storage class, which is multi-regional. I provide location US, and then I just name my bucket. Literally, there is nothing else you need to provide. We'll take care of everything else. We'll take care of where to store your data, and you don't need to worry about it. And when you retrieve your data, again, you don't need to specify any locations. You just provide your bucket name, domain name, and then name of your file. That's it. You don't need to worry about routing. We'll take care of routing within our network. You don't need to worry if it's East, West, Europe, US. We'll take care of all of that routing on our Google network. Multi-regional storage class is also optimized for end-user latency, because there are multiple layers of caching that we have in DCS. So even though you might be storing data in multi-regional US, if you have customers that are accessing the data from Europe, we'll cache the data in Europe in our data centers. Similarly, in Asia Pacific, we'll cache in our data centers in Asia Pacific. And on top of that, if you set your objects to be public, we'll also cache those objects at the edge in our points of presence. We have around 100 points of presence around the world, and we leverage the same infrastructure as for other internal Google products, or for instance, YouTube, and we'll cache the data in those points of presence. So your consumers in large cities around the world will have extremely low latency, because data will actually be served from location right next to them in that city. In terms of price, we charge very simple 2.6 cents per gigabyte month for your data in multi-regional storage class, and we'll take care of all the replications underneath. You don't need to worry about paying for network to replicate your data across data centers. You don't need to worry about secondary copy or tertiary copy. Everything is included in that simple 2.6 cents per gigabyte month price. We also charge for read operations and write operations, and we've recently decreased that price by 50 and 60%. We decreased it half a year ago, and we have very competitive price on storage and operations there. In terms of availability, typically the storage class runs at 4 nines availability, and we provide 3.5 nines SLA. So if for some reason it drops within a given month below 3.5 nines, we'll pay you back for using that storage class, depending on how available it was. And it's also designed for 11 nines durability. All of our storage classes are durable, so you don't need to worry about some storage class being less durable than the other. We provide the same standard durability across all of them. Turns out a lot of data is actually being consumed on mobile phones. So it's extremely important for our customers to be able to build applications and be able to serve the data and consume the data from mobile phones. So I'd like to invite Mike McDonald, who is a product manager on Firebase, to talk about using Google Cloud Storage with Firebase API.
Thanks, Kirill. How's everyone doing today? Good? Awesome. How many of you have heard of Firebase? A couple people. How many of you operate mobile apps? Hopefully, oh, come on, you guys, the world is mobile first. So what Firebase is, oh, I have a clicker. Firebase is Google's mobile platform. So Firebase allows you to develop your applications on Google Cloud Platform, grow your user base using our, we have push notifications, we have application invites, all of that kind of stuff. And we also have a monetization platform, so you can earn more money by integrating with our products. But for those of you who are building mobile apps, how many of your mobile apps are serving some kind of rich content? So you're serving media, you're serving images or videos. All of that, you need to be able to easily upload from the user's mobile device and then transmit those around the world. Firebase offers really great mobile support for Google Cloud Storage through our SDKs. And those SDKs, I want to go to the next slide, are optimized for mobile content delivery. So we handle tricky problems like really granular security. So if you want your users to sign in via Facebook and upload a photo, we can integrate with Firebase Authentication, which does serverless sign-on to Facebook, and then lets you, again, without a server, upload directly from your device to Google Cloud Storage, to any Google Cloud Storage bucket. We also do that on the clients. We have very robust networking. So how many of you guys are enjoying the conference Wi-Fi? Things are pretty slow. Are you like trying to send tweets and take pictures and share them with people? Have you had any uploads fail? It's because people aren't doing it robustly. So our networks are going to do, or our SDKs are going to do resumable uploads. And I'll actually show that because I've been having fun doing my demo earlier over this network. And so we're going to make sure that your uploads and downloads get to where they need to go, even if the network is terrible. And as Kirill's been talking about, it's all built for Google Scale, right? So we support 5 terabyte uploads direct from your mobile phone. And I actually have a standing thing. You can tweet at me. If someone ever finds out how to upload 5 terabytes from a mobile phone, let me know, because I have a job for you. So let's switch over to the demo, because listening to me talk about this is really not exciting. How many people have programmed an iOS app? Or does Swift code look at all familiar to people? Maybe? Hopefully it's not too crazy. I have, over here, an iPhone app, and it's going to look really boring when I start it up, because there's nothing going on. But if you click that little camera button, it's going to take us over to a photo picker. And what we're going to do is we're going to take a picture from the phone, upload it to Google Cloud Storage, and then download it again to the device. So we're going to do that all with Firebase. So this is actually about 100 lines of code just as a shell. But yes, this works. We are going to add, I didn't delete my sample. There we go. We're going to first upload the image. So we're going to create a reference to our cloud storage bucket. And then we are going to upload our image, just using this put method. And so that takes the image that we clicked and is going to upload that to Google Cloud Storage. We'll also add an observer to let us know the progress, because I was noticing earlier today it was pretty slow. So what this is going to do is it's just going to print out and let us know how quickly things are going. So I will rerun that. And to prove to you that this is going to work, the app will open up over here. We will select a photo. By the way, the Apple system photos are about 20 megs in size. They're pretty big. Oh, and there we go. Actually, the internet was pretty quick. So you can see that we fully uploaded our file. Let's pop over to the Firebase console and refresh the page. And we can go ahead and see we now have a folder that says Photos. And we even have the photo in there. That was like one line of code that uploaded a photo. You guys no clapping? Okay. Thank you. Small applause. We're not done yet. So now we're going to synchronize that. So we're actually using another Firebase product. It's our real-time database. And we've already written that data, basically a shareable URL for that location in cloud storage. And now we're going to download that image and display it. So all you need to do there is you can take that URL that we synchronized via our database and just say, get the data. And they're about 20 megs, so I'm making sure that we have enough. And then we simply put it in our app and reload. We'll go ahead and start that back up. And the nice thing actually about the database is it's going to immediately take the first photo that I uploaded last, and it's downloading it right now, and there it is. So that was actually pretty quick. But because I like to live dangerously and because I'm a millennial, I have another version of the app on my phone. And I am going to take a selfie with all of you. And let's see how long this takes. So it's uploading right now. And there we go. Oh, I'm upside down. Sorry about that. But there you go. So that was maybe 10 lines of code, including all of the application logic, to upload and download from Google Cloud Storage on an iPhone app. Thank you all very much. And back to Kirill.
Thank you, Mike. So all of that is still backed by Google Cloud Storage. So that means when you're leveraging Firebase, all of that data will be transferred by Google Cloud Storage, will be stored on Google Cloud Storage and transferred by Google Network. So it will be amazingly fast, and it will scale to extremely large applications that's serving that content around the world. So let's go back to big data analytics now. So if you have a lot of data, you need a place to store it before you analyze it, and Google Cloud Storage Regional bucket is the right place to store the data. So data with GCS Regional is redundant within a given region, and if you select Compute Engine and GCS Regional in the same region, you'll get the lowest latency possible between those two. And it's built for data access frequently, so that means if you have some application that processes the data a lot, this is the best storage class to use. Similarly to any other storage class, GCS is very deeply integrated with other products within Google Cloud Platform, like Dataproc, ML, Google Compute Engine, Genomics, even BigQuery. So you can potentially store data in GCS and query it directly out of BigQuery via federated query. And a lot of customers use the storage class to run different pipelines and analyze their data from either their custom pipelines in Google Compute Engine or via our products. And because it's so well integrated, it's very easy to get started, let's say when you're migrating from Hadoop on-prem, migrating to Google Cloud Platform. So one of our products in Google Cloud Platform is Cloud Dataproc, and it's essentially a managed Spark and Hadoop service. And we have a cloud storage connector, which is HCFS compliant as part of that product. And that means it's very easy for you to move from Hadoop on-prem to GCS and Dataproc. So here's the example at the bottom of changing your code, essentially just changing one line. It's how you're referencing your storage, and everything else, all the other code will keep working, and that cloud storage connector will take care of everything, and you don't need to change any other lines of code. And that solves a lot of problems for customers. Because data is stored in GCS, you don't need to worry about scaling the data over time, like you might need to worry on-prem. The data is also accessible outside of your Hadoop cluster. So you can turn it down, and your data will still be there. It's still in GCS. You can turn up another cluster and access the data. So that provides a lot of simplicity and a lot of flexibility for our customers. If you want to read more about Dataproc, you can go to cloudgoogle.com/dataproc. Similarly to our multi-regional storage, we charge a very simple price of 2 cents per gigabyte month. We charge also per operations, and we provide 3 nines availability SLA. So as you see, our SLA for regional storage class is slightly lower than the one for multi-regional, where we provide 3.5 nines, and that's because regional storage is not geo-redundant as multi-regional storage class. And it also has 11 nines durability. It has instant access like anything else in GCS, and we have exactly the same API that you would use across all storage classes. So once you start using regional storage class, you can easily switch to using any other storage class. But enough hearing from me. I'd prefer to hear from a real customer. So I'd like to invite Fastly, our dear customer and partner, and specifically Artur Bergman, their CEO.
Thank you. Thank you. This works? All right. Hello, everyone. My name is Artur Bergman. I'm CEO of Fastly, and we are both, as Kirill said, a customer and a partner of Google. So what we are is a edge cloud. So in the old world, you had a whole bunch of edge devices in your own data center, and as you're moving to the cloud, those old, expensive, inflexible, unreliable hardware machines that you had at the edge of your data center have no longer anywhere to live. And so that's where we come in. So we complement very well together with the central cloud, so we integrate really well with Google. So we provide caching, edge compute, TLS termination, load balancing, visibility as a complement to the storage and compute and et cetera that you get on the other side. So it works. We have interconnections with Google in quite a few locations around the world to the Google network. And then we have our own POPs all around the world where we store your content, process your content, defend your content to end users, whether those are humans or machines or et cetera, all around the world. And so could also at some point be described as a CDN. We have one really cool things that we found with Google is the cloud functions. So one of the core functionality we provide, right, is that you want the view that the rest of the world has of your content to be up to date. So we do cache invalidation or purging in about 150 milliseconds worldwide. And so here's a very simple cloud function for Google Cloud Storage. So when you upload or change an image or any piece of data on Google Cloud Storage, the cache invalidation goes out worldwide, and the new content is available from any edge pop, completely transparently. So we really like working with partners who are really, really good and provide really good performance and service and reliability to our customers. Because at the end of the day, we're here to provide fantastic reliability and performance to our customers. And if we bring in partners or work with partners who don't, that causes problems. And so I went and looked at some performance metrics that we're collecting from Google Cloud Storage versus Amazon S3. And this is not a synthetic test. This is actually looking at very, very large data sets of content being fetched from both. And the difference is pretty dramatic. So the scale on the lower is different, but what you're seeing there is an average time to first byte of 3 to 5 milliseconds versus 200 milliseconds. Right? And so, again, this is two very large data sets where we're fetching cache misses from S3 or Google Cloud Storage. And in both cases, it's S3 East and GCS East, which is one of the reasons we really love working with Google, because this just creates a better experience for everyone, both engineers at our customers and their end users. So the use cases we're looking at, and we have some pretty amazing customers together. Spotify, Vimeo, and Firebase was earlier, are obviously around caching close to the user. But also on the big data analytics side, we integrate really well. And from a security point of view, the real-time aspects of the platform and the integration with Google allows you to do some pretty amazing stuff. Use cases are, in this case, are pretty simple. On the face of it, like Vimeo is obviously video and images. Spotify is, as people can guess, a tremendous amount of audio. But there's a lot of other things, cool things that they do with us as well. We also do real-time log files from the edge, which is pretty key, because as you're moving functionality that you used to have in your own sphere of control, you need that, when you had it in your own data center, in your own control, you knew what was going on in real time. And you need that once you move it out into the cloud as well. And so we have these real-time logs that update in about a second, and we can stream those into Google Cloud Storage and then get that into BigQuery in pretty much real time. That's something we use internally very much. So you're kind of seeing that the two-way integration that just creates a really nice experience for engineers, for developers, and operations. So internally, we use that a lot for analyzing performance of TCP connections between end users and us. So we see on the order of 3-4 million TCP connections per second. At any given time, we'll have about 150 to 200 million TCP connections open. And we want to know as much data about these as possible to detect problems on the internet, route around those problems, etc. And what we ended up using is BigQuery. And we put in somewhere between about 50 and 100,000 records per second into BigQuery. We also use it for edge enforcement, which I'll go into in a second. And then we have customers who use it in the ad tech space, or for beacons, so they're collecting data through Fastly, and then instead of having to run their own data center, like their own servers, to terminate that request and put it into Google Cloud Storage, they're just having Fastly dump it directly into Google Cloud Storage. So, serverless, basically. We use it for edge threat analytics. So we have a WAF product, and we provide edge security for our customers. And so we use Google GCS and BigQuery and edge logs for that, and basically very quickly can pull any kind of report from the edge to see like what rules are hitting, what kind of threats we're seeing, anomaly scores, etc. And we can then expose that to our customers. So the total pipeline of end user fetching something from us, we don't have it, we fetch it from Google. If we have it, we give them, we process it, we apply whatever rules and logic around that we need to, and then we log it into Google, and then we use the Google tools for analytics. And so you can then integrate that with whatever pipelines you have for other kind of analytics, whether using Tableau or something like that, or one of the security packages. And it works really well. And then you can use the standard Google visualizations that they have to just create reports really, really fast. So the combination really lets you build a very, very compelling replacement to kind of the old combination of having your own storage and then have a boring CDN out there that doesn't actually do what you want it to do on either side. And that combination, that two-way integration really allows you to drive a lot of value. And the value really comes from two points. One is the customer experience, your end user experience. But I think a very important point is also the internal engineering and product experience, right? So it allows your developers, it allows your product engineers, your product managers to just move faster and to get new functionality out, because all the APIs, all the documentation, APIs, functions, modules, etc., are just so accessible and real time, and you don't have to go through this kind of painful process that you traditionally had to do to get all these systems working together. So you can just release code faster, keep your engineers happier, and keep by extension, your end users faster. So we're big fans of Google. We use them internally. We have very big customers together, and we would love to have more of you using both us and Google together. Thanks, everyone.
Thank you, Artur. So we've talked a lot about big data analytics and content serving, but all of those customers, they have some sort of cold data. So over time, they collect a lot of data, and that data may not be as commonly used as it used to be when it was just first generated. And typically, customers would want to save money on the data. I'm sure everyone wants to save money on their infrastructure, and if the data is not being used that often, probably you want to pay less for the data. That's why we have two storage classes that are designed for cool and cold data. So one of them is Nearline, another one is Coldline. I'll start with Nearline here. So Nearline is a storage class that's designed for infrequently accessed data. It provides the same instant access speed and the same API as other storage classes, and it's extremely important for our customers. So what that means, if you're using multi-regional storage class for content serving and delivery, and then turns out not all of your data is frequently accessed, and you want to store some of it in Nearline, well, it turns out you can use all of your integrations. You can use our partnership with Fastly to serve that content around the world, or you can use any big data tools that we have at Google Cloud Platform, and you don't need to change anything, because it's exactly the same API, it's exactly the same latency. You don't need to do anything extra on top of that. So some typical examples include storing historical data and then maybe analyzing the data in the future. So sometimes you don't know how the data might end up being useful for you in the future. So you want to keep it around and still probably have low latency and some chances to access the data in the future. Customers also use Nearline to serve long-tail content. So if you have a lot of different multimedia content, some of it will not be as frequently accessed as the other ones. So you can put your cold content or your long-tail content on Nearline. So for Nearline, we charge 1 cent per gigabyte a month on storage, and we also charge for access of 1 cent per gigabyte of data read out of Nearline. And if you work out those two numbers and storage price for regional and multi-regional storage, it turns out that Nearline becomes the cheapest storage class for data that's accessed less than once a month. And that's where that statement comes in, that Nearline is built for data that's accessed less than once a month. For Nearline, we provide SLA, we provide 2 nines SLA, and it's consistent API and consistent performance, like with any other storage classes. So if you've been with us for a couple of years, you might have seen Nearline 2 years ago, and back then we had 4-second latency on Nearline, and we've been working very hard on improving performance and reliability of Nearline and any other storage class. So over last year, we've increased availability SLA on multi-regional storage class, and we also decreased latency on Nearline all the way from 4 seconds all the way down to instant access speed with Nearline. And we're committed to continuously improve our performance and reliability in Google Cloud Storage. And those improvements that we've made with Nearline last year, bringing it all the way to instant access speed, allowed us to ship a new storage class that's called Coldline. We've launched it last October. And Coldline is best for cold data, specifically data that's accessed less than once a year on average. Similarly to Nearline, it has all of the integration points. It has exactly the same API, but because it's built for very cold data, customers usually use it for archive or storing multimedia source files. So if you don't expect to transcode your data that often, you would still want to have your multimedia sources somewhere, and customers choose Coldline for that scenario. And also disaster recovery. And that's a very important point with disaster recovery. In case something happens to your core data set, you want to be able to pull the data out very quickly. And usually customers cannot use tape media for this or any sort of media that has latency in it. And with Coldline, you have instant access speed, so you can start accessing the data right away. And more than that, because Coldline has exactly the same API as any other storage class, you can start serving directly out of Coldline or using data, the data that you're storing in Coldline for processing right away without any delay, because API is exactly the same. And customers find it much more simpler than any other solutions in the market that they have. They just switch the traffic to a different bucket, and they start using it. In terms of price, we charge 0.7 cents per gigabyte month for Coldline, and we also charge 5 cents per gigabyte on data access. And that works out that if your data is accessed less than once a year, Coldline becomes the cheapest storage class for you to use. We also provide availability SLA for Coldline. We provide 2 nines availability SLA, exactly the same as Nearline. And we also have minimal storage duration for Coldline at 90 days. So let me show you a little bit about that API and that performance. So people sometimes don't believe me, do you really have exactly the same API? Well, it's exactly the same. Here's an example of doing get or put, HTTP put with Coldline, and it's exactly the same API as you've seen a few slides back with multi-regional storage. You provide name of your bucket. In my case, it was Coldline. I was the one to claim Coldline as the name of my bucket. You provide your domain name and then your file, and that's it. It's exactly the same API as anywhere else. In terms of performance, here's an example of reading 1 megabyte out of Coldline. So we have a utility that's called GSUtil, Google Storage Utility, and I ran perf diagnostic with that utility and downloaded 1 megabyte file from Coldline. And as you can see here, it's between 150 and 200 milliseconds to download 1 megabyte file, which is quite impressive. Many customers cannot achieve this with their other solutions for hot data, and we achieve this with Coldline, less than 200 millisecond latency to pull out 1 meg file out of coldest tier that we have. So we see a lot of customers tiering the data from hot storage to cold storage, but they can also tier their storage from on-prem all the way to cloud and all the way to Coldline. So I'd like to invite Karthik Ramamurthy, who is Director of Product Management from Dell EMC, to talk about our partnership and tiering to Google Cloud Storage.
So for folks of you who don't know me, my name is Karthik Ramamurthy, and I'm part of the product management team for Isilon, which is part of the Dell business unit. So Isilon, we started as a company back in 2001 with a focus on trying to build out a scalable NAS platform to serve the needs of some specific verticals, right? Specifically to life sciences, to media and entertainment, specifically customers who need a lot of unstructured data and a lot of highly throughput and highly scalable data. Over time, the company's grown as part of EMC and now part of Dell. We've got over 8,000 plus enterprise customers using Isilon. What makes Isilon unique to all of these customers and why they continue to invest and buy more of Isilon is because it's a platform that's highly simple to manage. It's extremely scalable. We've got all of the enterprise-grade capabilities that customers expect on a platform, and all of the enterprise-grade security elements to it, everything from SEC compliance to typical security tools. So all of the capabilities that a customer requires on the enterprise is now all available for your scale-out NAS platforms as well, right? What makes all of this very interesting to a lot of customers is the fact that you have that same level of efficiency and scale as the amount of data starts to grow. And for many of you who manage the data today, you know that the largest part of your data that's growing is your unstructured data, which is roughly growing at about, as Market says, roughly about 3 times the rest of the enterprise, right? And so being able to have a single user experience for your data, which is both structured and unstructured, is what customers look for, right? And that's kind of where we, from a business perspective and from an Isilon perspective, approach the build that we do, right? Which is give customers the exact same experience, whether they're running the data on the edge clusters, whether they're running the data within a core data center, or whether they're running it in the cloud, right? And now what makes the cloud interesting is customers look at cloud both from a data mobility perspective and from a flexibility perspective, but also looking for ways to be able to offer lower cost storage for some of their warm, hot, and potentially even cold data, right? So from an EMC perspective and from a Dell perspective, we've got our own solutions. We've got a product called Elastic Cloud Storage, which allows customers to move data between Isilon and an on-prem storage. Now, what makes on-prem storage interesting is it gives customers the ability to access the data within the same protocol timeouts, within the same expected reliability and response times from the cluster. Now, what that means is when we started looking at, okay, we've got an on-prem solution in the form of Isilon, we've got an object platform which is also on-prem. Customers are looking for off-prem solutions. Customers are looking for public cloud solutions. And so we started to look at a number of cloud targets that we can support. And a key element to supporting different cloud targets is, can we have a cloud target that enables customers to get the dollar per terabyte that they need for their storage? And also, can they get the predictable SLAs and the predictable latencies in terms of access to the data, right? And that's what brings us to partnering with Google. Obviously, as a very important partner for us, is enabling customers to start to tier all of their cold data from the Isilon onto a Google Cloud Storage target, right? So customers today using Isilon can put their performance data, their high throughput data on a local on-prem Isilon cluster. But as the data starts to age and the data starts to get cool, you can start to move it off to a Google Cloud Storage target and still be able to access it within the same namespace that they would with the data on-prem, right? What that gives customers is essentially a seamless experience, right? Whether the data is on-prem, whether the data is on a different tier of storage within the cluster, or whether the data gets tiered off to a Google Cloud Storage target, you get the same experience from a cluster perspective. You have the same security credentials, you have the same enterprise features. It's largely agnostic and it's largely transparent to the customer whether the data is on-prem or whether that's in the cloud. And that's important for a lot of the enterprise customers, and I'm sure a lot of you all can relate to that as well, is your end customers and end users essentially are going to say, here's what I need from a storage perspective, here's the expected SLAs, and here's the expected performance characteristics that I expect from a storage. You, storage vendor, go figure out how do you provide that to me. And for us, being able to do that with a vendor like Google enables customers to make that choice of whether they want to keep the data on-prem or in the cloud, but essentially keep it seamless for them.
So we've talked about tiering data from on-prem to Coldline and to Nearline. Turns out that many customers want to tier the data from hot storage to cold storage as well. So before we go into tiering, I'd like to remind you all of the storage classes that we have in Google Cloud Storage today. So we have 4 of them. It's multi-regional, regional, Nearline, and Coldline. So 2 left ones, multi-regional and regional, are hot storage classes. Multi-regional is geo-redundant across 2 or more regions that are 100 miles apart. And then regional is designed for hot data stored within a single region. And multi-regional is typically used for content storage and delivery, and regional is typically for big data analytics within a given region. Then we also have 2 storage classes for cool data. That's Nearline for infrequent access data. And we also have Coldline storage class. That's for data that's accessed less than once a year. That's typically archive and very cold data. And across all of them, we have the same durability, 11 nines. We have the same instant access speed. We have the same API across all of them. One interesting feature that we shipped last year was object-level storage class and data lifecycle across those storage classes. So we see many customers wanting to use multiple storage classes at the same time and age out their data from hot storage to cold storage over time and pay less over time. And we've seen customers copy the data from hot storage to cold storage, and when they decide they need to use it, they'll copy it back. And that was quite inefficient for customers, so we wanted to make it very simple for them and simplify that they don't need to worry about that. So we've created per-object storage class. With per-object storage class, you can keep your bucket, you can keep your name of your objects, and you just change settings on a given object and say, now this object is Nearline, or now this object is Coldline, but everything stayed the same, so buckets, object stayed in place, it's the same object name, the same bucket name, the same API call. So if your application was using that object, it wouldn't notice any change, and everything will keep working as intended. And we also ship data lifecycle across storage classes. You can create a simple policy that will say, if my objects are older than 30 days or some number of days, move them to Nearline. As we see, a lot of customers use their data very frequently within the first 30 days, but then they no longer use the data after that, after those 30 days. And typically, they would move the data to Nearline, and after a longer period of time, they'll move it to Coldline as they don't expect to use the data much longer. So what's cool about this per-object storage class and our consistent API across those storage classes, once data ends up in Coldline, you don't need to worry about restoring it back or copying it somewhere. You can keep accessing against the same API, against the same object name. And that provides a very simple solution for our customers to tier data between hot and cold storage. I like to compare us to S3 because there are quite a few areas where we're winning. So starting from the far right is multi-regional storage, and our competitor does not have really direct competition in that area. So you could create a S3 standard with cross-region replication, and you would need to pay for 2 regional copies, and you would need to pay for network to replicate across those 2 regional copies, and that adds up to much higher number of like 4.2 just for storage, 4.2 cents per gigabyte month, plus network to replicate across 2 regions. And with us, we have a much simpler solution with multi-regional storage. You just create one bucket and we'll take care of everything for you. You don't need to pay for second copy. You don't need to pay for network to replicate it. You don't need to worry about failing over between those 2 regions. If one of them goes down, we'll take care of all of that for you. And because we provided simple API, all of our storage classes have exactly the same API and exactly the same performance. You don't need to configure anything extra outside of those storage classes. So then if we move to regional storage, that's for hot data accessed within the region, we have a quite comparable product. It's GCS regional versus S3 standard, and we are slightly cheaper than our competition around the world. And then going to infrequently accessed data, we have GCS Nearline, which is at 1 cent per gigabyte month, and our competition charges 1.25 cents per gigabyte month, so again, slightly cheaper there. And then going to cold storage, so we have a product that's called GCS Coldline. We launched it 5 months ago. And with Coldline, we have the same API and the same latency characteristics as any other storage classes. And that means customers don't need to worry about integrating with it or treating it differently like anything else. And there is no direct competition in that space. So when customers think about storage and comparing it to Amazon S3, usually they think it's apples-to-apples comparison between Google Cloud Storage or GCS and S3. But turns out with S3, you need to add a lot of different layers to compare to what GCS provides. So if you want to use really cold storage, you need to add Glacier. You need to figure out how to integrate with it. You need to restore data out of Glacier before it becomes usable. If you want to have multi-regional storage or geo-redundant storage, you need to use CRR, which is an extra API for you to configure those regions and failover between them. If you want to use high throughput network, or if you want to get high throughput for your data, you need to use accelerated transfer, and they charge extra for that. With us, we don't charge anything extra. All of your data is accelerated out of the box because we use fantastic Google network to transfer your data. And then if you want to use CDN, you need to include CloudFront with Amazon. With us, edge caching is part of the product. And as you've seen from Artur, we have fantastic latency because of that, because we have so many different tiers of caching, and it's part of the core product that you don't need to pay anything extra. You don't need to configure anything on top of that. It's just part of our simple Google Cloud Storage. To summarize, we have a large portfolio that covers many different use cases. So we have a multi-regional storage class that's perfect for content storage and delivery. We have regional storage class that's perfect for big data analytics. We have Nearline for infrequent access data, and we have Coldline for cold data. All of those storage classes are united by the same API, the same online latency, the same network, the same peering that we have at Google. Now we have lifecycle across those storage classes that you don't need to worry about configuring or copying any data between those storage classes and then changing your API. Everything is very smooth for you right now. And we also have lots of different partnerships that help you integrate and help you use Google Cloud Storage in any scenario that you might have. So you can learn more about Google Cloud Storage at cloudgoogle.com/storage. And you might have heard that this morning we've announced much larger free trial with Google Cloud Platform, and we also announced free tier, which includes Google Cloud Storage now. So everyone has access to free 5 gigabytes in the United States, and it doesn't expire. There is no limit on it, so it's free tier. Feel free to use it, and feel free to try out Google Cloud Storage. So we have quite some time left, so maybe a few questions if there are any questions in the audience. So we had 3 guest speakers, so all of us can answer your questions. And I was asked if you have any questions, please stand up and walk to the mic. It's because we are recording, so that we'll hear a question in the recording as well. Yeah. Thank you.